Hi there. This is the second to last video. I thought it was the last one, but there's one after this on solving triangles. This is such good practice for those primary trig functions and Pythagorean's theorem, because you have to look at what you've got and then you make your decision. It's not like you look at the question and it says use Pythagoreans, use sine. No, you have to use your brain. So let's see what we got here. All right, so we have a 90-degree angle. And we have two sides, and there's no angle. So no angles means you have to start with Pythagoreans. So we are going to find this side. Oh, I don't want to label it. I guess we're solving for little l. All right, so hypotenuse squared is equal to side squared plus side squared. If you are used to using c squared is equal to a squared plus b squared, cool. I can handle that. I just find this easier because it reminds me and the learners that hypotenuse is the one all by itself on one side. So we got 9.5 is equal to 6.8. Whoops, I lost my squareds. Plus side squared. If you wanted to put the 6.8 over there, that's fine. All right, 9.5 squared. 9.5 times 9.5. All right, there we go, 90.25. .8, or I can use my squared button. 46.24 plus side squared. So this is where you have to be careful, because a lot of times if you're not paying attention to, you just automatically put them both on that side. So this is the hypotenuse. I think any and all triangle questions that have a right angle in them, the first thing you should do is put the hypotenuse in. It will never, ever, ever, ever hurt you, and it's probably going to save you some craziness later on. All right, so now I'm going to subtract 90.25, subtract 46.24, right? Because I'm going to go minus 46.24 here. I got to do the same thing. And I'm going to get equals 44.01 is side squared. Now, that can't be the right answer because this is side squared. Square root both sides. Second. All right, so 6.6 is equal to my side. Oops, centimeters. If there's units in the question, put units in your answer. And up here, it was rounded to 1 decimal place, so I rounded this to 1 decimal place too. So that is the joy of Pythagorean. And, oh, I was about to put the 6.6 there, and I was like, hey, that's the hypotenuse, it's got to be the longer. Well, yeah, my bad. The 6.6 goes here. There. Okie dokie. Now, let's find angle L. That looks horrible. Let me try that again. There. Okay, so this is the one I care about. Now I'm going to use my primary trig functions. I don't know which one at this point, but I know I can use it because that's the only way I can. They're the ones that deal with angles. If you have an angle or you need an angle, you're going to be using one of sine, cos, or tangent. But I better do some labeling because I don't know. Okay, there's my hypotenuse. I'm going to find angle L. So we go around here. This is going to be adjacent, and this is going to be opposite. All right, so I'm going to use these two because I have the numbers for it. I don't want to use that 6.6 because I made a mistake. I'd rather start fresh with the numbers in the question because I know those are exact and I know they're right. So I have adjacent and hypotenuse, that's cosine. So cosine L is, oopsie, adjacent over hypotenuse. I keep switching between leaving the beta there and putting a letter in. Either one is fine. I think this should make it a little more clear for you guys. So I'm going to get rid of my thetas for a second. I'll put the letters in right away. So angle L, which I don't know, is equal to the adjacent, which is 6.8, divided by the hypotenuse, which is 9.5. Handy dandy calculator, 6.8 divided by 9.5, 0.71, well, sorry, move that over there so I can actually write, 0.71, and I need a 5, and you can see the 7 here, there's an 8 after it, so that makes it go up 1, 8. Now, that's not my angle. I want my angle, so I'm going to have to go second cos, and on my calculator, I can just hit the button and it goes automatically. If you had to retype that, oh, hold on, let me write that down. Cos, oopsies, no, we're at angle L is equal to 42, goodness. Okay, let's just start a whole new line. Angle L is, I'm going to write 44.29206. Bear with me, I'll explain that in a minute. Okay, so my calculator didn't round at this point. It used all the possible data that was in it. Okay, so all the numbers that were there. If I, on the other hand, go second cos 0.7158, okay, if I type that in, that would be better. 0.7158. Okay, I get 4429. Oh, look, by the third decimal place, there's a slight difference. And that's because this number is rounded, whereas when I did this part, it wasn't. But the truth is, when I say round to the nearest degree, it will make absolutely no difference. So it doesn't matter to me. 44 degrees. By the way, that whole thing about rounding, that is not going to matter until you hit finance in Math 30. Then you're going to learn some magic on your calculator so that you carry all the decimal places with you, and then you don't lose out a few pennies at the end. I hear with accounting, it's really important. Okay. I could go 180 minus the 90 here, minus the 44 there, and get the other angle, but I don't want to. Okay, and I don't want to because if I screwed up here, then I'm going to carry my error forward. As it is, because I rounded, there's still going to be a slight difference. So let's find angle M. All right, so for angle M, and remember what happened? This is so cool. Okay, so I'm going to get out my handy dandy green pen here. So I care about angle M this time. So now, oh, by the way, if you don't like me flipping pen colors, you certainly could redraw your triangle. And I'm going to go around to M, which makes this side adjacent. And this side becomes opposite. Remember, they do flip-flop. If you flip-flop your angle, adjacent and opposite are going to swap for you too. So now I know my hypotenuse. Still know my hypotenuse because it doesn't change, but I know opposite. And hypotenuse and opposite is going to be sine. So sine M is opposite over hypotenuse. Sine M, opposite side is 6.8 over 9.5. Now, if you're going, hey, wait a minute, we just did that? Yep, we did. It doesn't matter. Those numbers are still going to be the same. The hypotenuse doesn't change, so the 9.5 has to be on the bottom. So sine m is going to be 0.7158. Show you 68. Oopsies. 6.8 divided by 9.5. Oops. There you go. 71.58, just like before, and then I can do second and sine. And I'm going to get m, angle m, is equal to 45.7. So that's 46 degrees. And there we go. Now, let's do our multitude of checks here. Okay, first one. All the angles of a triangle add up to, yes, 180 degrees. So let's see. So we got the 90 degrees in the corner, plus the 44 we calculated for angle L, plus the 46. And I know that adds 280 degrees. So we're good there. So my angles make sense. Another thing we can look at is, let's see. If we look at our sides, so N is our biggest angle. It's across from 9.5. That's our biggest side. And we just figured out that 44 degrees up there, that is angle L. And we said this one over here is 46. So I'm going to put that in there. Oopsies. This is my smallest angle. So it's going to be across from my smallest side. And I'm going to add something new this time. You notice that 44 degrees and 46 degrees are really close together. So the difference between like the middle angle and the smallest angle is pretty close. You will also notice that 6.6 and 6.8, those are really close too. If each of those angles was 45 degrees, those two sides would have been exactly the same length. Just saying. And that would have made it an isosceles triangle. Okay, enough review. Angle L, let's fill in the box here. It's 44 degrees. Angle M is 46 degrees. And angle N is my freebie of 90 degrees. Now let's go with our letters. We go across here. This is a little n. We go across this way. This little m. And we go down this way. Oops, I already had little l there. So little l is 6.6 centimeters. Or include the units if there's units in the question. M is 6.8. And n, where'd it go? Where'd it go? Where'd it go? Over there is 9.5 centimeters. And ta-da! We have checked everything we possibly can, and I think the question is wonderful and delightful. Thank you for playing along.